So I think this is going to be quite an interesting video today. I have a code base here. So this is a personal project that I've been working on. I've been working on it with the heavy use of LLMs, and I created this Claude MD file recently, which a lot of people had quite a interest in. And I was really kind of experimenting with pushing the LLM to go in a test first manner, right? And that's great, and it's been working pretty well for me, and I've been making quite good progress on it. I've been pushing it really hard recently to make sure that there's no gaps in testing at all. So let me just run my test command with the coverage flag. Now, this is the React app inside my project, and it's going to run all the tests and a coverage report. So you'll see that here. Okay, 100% coverage, right? Now, I've been quite careful here to not just chase coverage. What I've been trying to do every step of the way is verify that the tests are good, that we don't have any holes. When I do this normally myself without LLMs, I'm really careful about how I do it. I go test first, and it gives me very high confidence that I've not broken anything as I'm kind of working through the code base. But it's a bit different when you're using an LLM because you can check it, you can try and be as thorough as possible. But I've had this niggling doubt that maybe some errors are actually getting through. So how can that be possible, right? If you see 100% coverage reports only tell you that the code is executed when the tests run. It doesn't tell you that you're testing the right things, that all the business behaviors have been captured. And it doesn't tell you that the test would fail if the logic was actually broken. So I've been using this tool. It's called a mutation testing tool, and I'm just going to show you what this has given me. Just before I do that, actually, I'll quickly explain what this is. So it's called Stryker, and what this tool will do is rather than just kind of have this kind of vanity metric, which just looks at whether the tests actually execute, the code executes when the tests run. What this will do is it takes a list of all of these mutants. They call them mutators. And what happens is, so like, let's have a look. So we've got, like, for example, conditional expression. So what it will do is when it finds a conditional expression in your code, it will deliberately mutate that code in such a way that it should break, that logically it must be broken, and it will see whether the tests catch that error or not. And these are called mutants, and any mutants that survive, that is, that your tests your tests don't pick up, well, they're called surviving mutants, right? And the idea is that you should have as few as possible, ideally maybe none. So you can see here we've got a big list of them, less than to false as an example here. So what's this doing? So if you see here, we've got a for loop with a less than inside it, and you can see here that the mutated version of this would change that to false, and then just run the test and see what happens. So I did this on this code base with 100% coverage, and look what I got back. I got loads of holes in here. It's quite interesting. Now I can go in here, so I'm gonna take a little bit of a dive in here. I'm gonna look at a specific component, this pagination component, and you can see here a very clear report. It's telling me 16 survivors overall. Let's take a look at this. So what is this doing? Now, there's some logic here to determine whether the pagination component should be disabled or not. And you can see here the logic is taking total pages, and if total pages is less than or equal to 1, then is disabled becomes true. See these red dots here? If I click on it, it shows me the surviving mutant that it tested. So it can see here that although the tests execute this code, it's not really testing this logic at all, because you can just change it to false and the test passes. So let's see if that's actually true. So if I go into cursor here, and this is my pagination component here, and I'm going to change this to false as it did there. Hit save, and I'm going to run these tests again. Now, it should, you would hope that this would cause a failing test, right? But we've just seen from the mutation testing report that it doesn't. So this is really interesting because it gets to the very root of what our tests should really be doing and what they really should be about, right? Because there's a business rule there that we should care about, isn't there? Otherwise, there's no need for this logic to exist. So what should be the case, and to be fair, if I was going test first my normal way without having the LLM kind of race ahead for me, the trigger for writing new implementation code when you are doing test-driven development is a failing test, right? And I always write tests against business behavior. So I would have a test somewhere that describes the expected business behavior here. So that, this pagination component, pagination should be disabled if total pages, if there are one or fewer pages. I mean, actually, fewer doesn't really make much sense, does it? But do you know what I mean? The point is that there should be a test that tests this business behavior. So what's really interesting about this now is that there are certain different kind of categories of tests that it's identified, or that we can kind of identify by kind of going through this report. So let me just check my notes here. Sorry, there was another one. Yeah, so there's a component called location bar, and I wanted to show that because it's a slightly different type of failure here. So if I go, I think it was the connected version. Yeah, here's very interesting, right? So in this one, I can tell you just from reading this code that this scenario just actually can't happen, right? That's the key thing here, that we've got this kind of defensive code that in this instance the LLM has added, but it's just pointless. Like this could never actually happen. You don't need to know the ins and outs of how this logic really works. The point is that we found redundant code here. So there's a huge value to something like this, right? And not just for if you're not just for working with LLMs. When you see a report like this, it's a trigger to, or it should be a trigger for you to go into the code and then kind of mutant by mutant, if you like, or surviving mutant by surviving mutant, have a look. What is the underlying reason that this code exists? What's the underlying business logic that we've missed here? We should patch that up. Or you might get a scenario like this where actually we don't need this code. This is just silly. This can't even happen. Or this was never a requirement. It's just been added in. So we can remove that code, right? So my solution to this part will be to just remove that. And then in other areas, it's to really go through and find what we really have missed. So, and I would like to be quite clear about this, that when I do test-driven development, I do suspect that I would have far fewer of these issues. Everybody's human. You can, anybody can make a mistake at any point. But this to me is an extremely powerful tool and something that I don't think is used very often in the industry. I will be transparent about this as well. I've never used this in a real world application to this point. I have actually, I do a kind of manual form of mutation testing. That's something that I sometimes do if I'm reviewing somebody's code. I don't personally like, the traditional pull request kind of way of reviewing code. I prefer to pair program as we're working together. It's probably a whole video in its own right about why I don't really like pull requests. But if I have to do it, or I'm working in an environment where that's how things currently work, one of the techniques that I've done for years actually is I'll pull people's code down. I run the tests, see them pass. They should normally pass because somebody's saying that this code is good to merge. But I will go in and manually do things like that on their branch and then run the tests, right? And you'd be surprised, or maybe you wouldn't be surprised, depending on your experience level, I guess. But very often you find gaps by doing things like this. Now, some people might look at this and say, well, isn't this overkill? Do you really need to do this? You really need this level of confidence? But if you're thinking about, I think you need that level of confidence, certainly if you're using, AI tools, because you want to be able to keep on moving with high confidence over time. If you're relying on test automation to give you that confidence, and even if you have 100% coverage, this isn't really tested, you could very easily introduce subtle bugs into the code base without realizing it. Do you see? And this is a huge problem. Now, that's the same whether you're using LLMs or not. So hopefully this does kind of illustrate why 100% coverage isn't, it's not what people often think it is. What I will say is, in defense of 100% coverage, because I often track it in projects that I'm working on, and I even have rules that enforce it in CI, and some people might think that's weird, especially given everything I've just said. But you have to understand that I'm coming from a perspective where you go test first, right? And when you do that, you get 100% coverage pretty much for free. You just get it out of the box. You're not chasing coverage, right? And on top of that, these kind of mistakes, I'm not going to say they don't happen, because I've never ran mutation testing against my own kind of professional code, and I'm interested in doing that now, and I'm going to probably do that pretty soon, actually. The downsides to this at the moment, so it takes a long time to run. That's one of the biggest downsides. Like, the very first time I ran this report took me 30 minutes on this machine, which obviously is way too long to run in CI just like that. However, and I'm still relatively new to this tool, so I'm still learning it, but this looks interesting to me. There is this incremental mode. And if my understanding of this is correct, and I think it is because I've tried it locally and it seems to work how I was expecting, the way I believe that this works is that if you store the report, if you store the report or a version of the report, and then you run the test again, it's clever enough to only run the mutation test, I believe, against the things that have changed. In which case it becomes a lot faster. So when I ran it a few minutes ago, it just took about 2 minutes, whereas it took 30 odd minutes the first time I ran it. Now, my thinking on this right now for my own project is I'm going to start running this locally myself, pretty much for every piece of work the LLM does. And I'm not going to let any mutants get through. I'm not going to run it on CI just yet. I'm going to try to do that if I can figure out how to get this incremental flag working and working really well. Another thing that I'm kind of thinking about doing is having it do a complete report, a complete run on a timer, maybe once a week, something like that on CI. I think also in my own code base, what I'm planning to do is to go through and really go through all of this and really understand, what things matter, what things don't. You can see here, it has active context, and that's been switched from false to true, and therefore, and it doesn't fail when it shouldn't. And again, look, some more defensive stuff. I suspect that there will be a mixture of code that I can just delete because I don't need it. Like, a lot of these fallback things probably don't need. I'd need to go through it and properly check it. And then other cases where I need to backfill those tests and to make sure that the business behavior has been captured. But yeah, I just thought it was a really interesting example, and this is very useful outside of LLMs and AI. It just seems like something that probably should be much more common in the industry. To be honest, it's you can just see how valuable this is. And I'm going to go through over the next I can't work on this all the time because I'm so busy in my personal life. So but I'm going to go through and I'm going to try and get this right up there. The one thing that is interesting is I did find an example before. I don't know if I can do it now because I'm kind of doing this in real time. But oh yeah, this thing I got lucky. Here is an example of one that I actually don't care about. Um, and that might seem a bit odd, but the reason I don't is because this is testing some CSS logic. Essentially, this CN function essentially gives you variants in CSS. Now, I tend to not test drive CSS. I do under some conditions, right? So I will if it's anything related to accessibility, for example. I also will if there's a real business behavior associated with some, dynamic styling. So, for example, um, I don't know, you click something and click a button, and I don't know, an element disappears on the page or something like that. I don't know, you can't think of examples off the top of my head, but something like that where something disappears or appears under certain conditions. That is a kind of business logic, right? As far as I'm concerned, on the front end. So I would test that. But stuff like, this to me is just styling, and I tend to not do this because I think your test can get really tightly coupled to like CSS classes, and it just gets messy. And I care much more about behavior in general. But the interesting thing here is I'm not quite sure how I can ignore this. I'm sure there's a comment I can put in there that will ignore, if I just put it above this block of code. But maybe I need to kind of investigate. Is there a way that I can identify this kind of block and just ignore that en masse? Maybe there is, maybe there isn't. I don't know. I need to look into that. But anyway, yeah, I just wanted to kind of share this with you all, and yeah, I think it's a really kind of interesting tool, and something that probably we should play about with a lot more in the industry. Yeah, that's pretty much it. Thanks.